Semiconductor Packaging. John D. Thomas, Alex Ruth. Book 2, Section 2, Chapter 5, Topic 5. DOE Techniques for Capturing Variations. DOE techniques provide effective tools for capturing manufacturing and material variations and analyzing their impact on process outcomes. Some common DOE techniques used for this purpose include: 1. Factorial designs. Factorial designs allow engineers to study the effects of multiple factors and their interactions on process outcomes. By systematically varying process parameters and material properties, factorial designs enable the identification of significant factors and their optimal settings. 2. Response surface methodology, RSM. RSM is a DOE technique used to model and optimize process responses as a function of multiple input variables. By fitting mathematical models to experimental data, RSM helps quantify the relationship between process parameters and material properties, allowing engineers to optimize process performance and minimize variability. 3. Taguchi methods. Taguchi methods are a DOE approach that emphasizes robust design and parameter optimization to achieve performance targets in the presence of noise and variability. Taguchi methods involve orthogonal arrays and signal-to-noise ratios to identify robust process settings and minimize the effects of manufacturing and material variations. 4. Monte Carlo simulation. Monte Carlo simulation is a probabilistic modeling technique used to simulate the effects of random variability in manufacturing processes and material properties. By generating random samples from probability distributions, Monte Carlo simulation allows engineers to assess the sensitivity of process outcomes to manufacturing and material variations. Applications of DOE analysis in manufacturing. DOE analysis finds diverse applications across various manufacturing industries, including: 1. Semiconductor manufacturing. In semiconductor fabrication, DOE analysis is used to optimize process parameters such as etching, deposition, and lithography to improve yield, minimize defects, and enhance device performance. 2. Automotive manufacturing. In automotive assembly, DOE analysis is employed to optimize welding, painting, and assembly processes to ensure product quality, reliability, and safety. 3. Pharmaceutical manufacturing. In pharmaceutical production, DOE analysis is utilized to optimize drug formulation, mixing, and packaging processes to ensure product efficacy, stability, and shelf life. 4. Electronics manufacturing. In electronics assembly, DOE analysis is applied to optimize soldering, assembly, and testing processes to improve product reliability, performance, and manufacturability. Conclusion. Capturing manufacturing and material variations in DOE analysis is essential for optimizing processes, improving product quality, and minimizing variability in manufacturing operations. By understanding the impact of these variations on process outcomes, engineers can identify critical factors, optimize process parameters, and implement robust quality control measures to ensure consistent product quality and reliability. DOE techniques provide effective tools for capturing and analyzing manufacturing and material variations, enabling manufacturers to optimize processes, reduce costs, and enhance competitiveness in today's dynamic manufacturing environment. Thanks for watching. Please like, share, and subscribe.